This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus, episode 644. We've got a great show with Kevin Hart, the CEO of Haven IAQ. We're calling it Linking IAQ and HVAC with Sensor Technology. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. I also want to mention our new Afterthoughts program, afterthoughts.iaqradio.com, sponsored by First On-Site. Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association, AIHA.org, the American Conference of Governmental Industrial Hygienists, ACGIH.org, the Cleaning Industry Research Institute, CIRI Science.org, the Indoor Air Quality Association, IAQA.org, the Restoration Industry Association, restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org, Healthy Buildings America 2021, HB 2021-America.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, Gray Wolf Sensing Solutions, GrayWolfSensing.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to Victor Cafaro, Chesterfield, Virginia, who was first to identify both John Lloyd Wright as the inventor of a toy modeled after a construction method used to build the earthquake-proof Imperial Hotel in Japan, and the toy as Lincoln Logs. The IAQ Radio Trivia question for today, November 5, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for the monitoring of indoor air. Learn how to expand your IAQ investigations at TSI Inc. Now, here's today's IAQ Radio Trivia question. Name the method used for determining variable distance by targeting an object with a laser and receiving the time, and measuring the time for the reflected light to return to the receiver. Back to you, Joe.
All right. Kevin Hart's our guest today. He's the founder of Haven IAQ, founded that back at the tender age of 23, after experiencing high levels of crystalline silica dust on industrial work sites. He conceptualized a wearable air quality monitor for global citizens that could crowdsource outdoor pollution data from thousands of devices. He was named the best invention of 2015 from Time Magazine and Popular Science. Now their product line, Haven, has been granted multiple patents and patents pending on its in-duct sensing and IoT controls, and are pursuing the mission of transforming millions of homes into safe havens. Welcome to the show, Kevin.
Thank you. Yeah, it's nice to be here.
It's great to have you. I was reading a little bit on your background. It's interesting. How were you exposed to high levels of crystalline silica? I mean, you were I read that you had done some HVAC contracting in your youth.
Actually, I was an electrician, journeyman Red Seal electrician. So we had a program where in high school you could get a trade and pretty much be ready to go by the time you graduated. And so I was working on construction sites and doing everything from the initial forming of the concrete, rough in finishing. And a lot of that was drilling into concrete, where you would see concrete dust pouring and then quickly become invisible in front of your eyes. So we had to wear these respirators, these purple masks with cartridges. And every lunch we would have a safety meeting. And that's really where I got introduced to the potential invisible threat of air pollution.
And that gave you the idea for a wearable air quality monitor?
Yeah. So at that time, there were regulators that were looking to control the amount of crystalline silica dust on job sites. And despite the good intention of regulating, the monitors weren't actually available or affordable. So nobody on the job site, whether it was the CSO on the job site, whether it was the employer trying to stay in compliance, or even the regulator, nobody had the technology to detect what the levels were of crystalline silica dust. So there seemed to be an opportunity to be able to affordably, accessibly detect what was in our indoor environment.
And how did that go? It was the best invention of 2015, but it seems like maybe it's kind of, I don't know if it's gone by the wayside, but it's not your primary focus anymore.
Yeah, our vision has stayed the same. The mission has stayed the same. And I think everyone in this industry has a similar mission, which is let's keep humans healthy, especially in their indoor environments. Yep. And what ended up happening with that specific product, we developed what initially started out as essentially a better smoke detector that you could wear on your belt. We miniaturized it. We came up with an affordable way to have lasers inside of the product. We identified a problem, which was this crystalline silica dust, and people were walking around collecting this data. At the end of the day, we realized that despite knowing that your air quality isn't good, we need to be able to solve it. And so there could be an alert to say, put on a mask. We realized that there was a bigger opportunity to solve this problem in contained indoor environments where the component of a wearable wouldn't be necessary because the sensors would be built into the building itself. And the solutions, for example, ventilation filtration, would be in the building and could be activated to solve the problem. And so it was really just an epiphany that we don't just want to be a bad news product producing data and insights. We actually want to activate solutions, solve problems for millions of people.
Now, where did you get your knowledge of, IT, like, sensors and particle counters and so on and so forth? I know you went to the British Columbia Institute of Technology at one point. What's your background in that area?
You know what? I don't have, I guess, the credibility of developing sensors. And so my journey has been one very much of entrepreneurship. And it's been not a straight line to get here. We have hired some of the top engineering physicists from a local university to work on this project, to create the technology, prototype it, iterate on it. And eventually we've been able to file and have granted patents. So really it's been a collaboration with people who are really intelligent when it comes to optics and electro-optics, when it comes to computational fluid dynamics, when it comes to miniaturization of sensor technology, or when it comes to building the radio frequency antennas and connectivity into our products. So it's not me leading from a technical side, it's me more leading from a business side.
And was there any crossover between the earlier, personal monitoring and the monitoring you're doing now in buildings? Was some of the, equipment similar or some of the sensors similar?
Yeah. Actually, our early focus, because of the crystalline silica dust, was sensing of fine particulates in the air, which ended up mostly just being PM 2.5, which I think a lot of the audience would know. And so those little particles floating around the air, we wanted to be able to count them. We wanted to be able to ideally bin them into different size ranges and even extrapolate what volume, what concentration of particulate matter was in the air. And so that technology that we had built was the exact same technology. It was the exact same sensor we had developed for the early wearable iteration, ended up being inside of our heating and cooling in-duct monitor that we sell now. And actually, one of the interesting, I don't think we would have ever got to where we are if we hadn't built the wearable, because we were realizing that people could put this in their pocket. The wearable device would be in their pocket. It wouldn't be getting airflow. And so it couldn't sense properly. It would say the air is clean. simply because it's not getting any air exchange within the wearable device itself. So we built an air velocity sensor into the product, which ended up being our sensing mechanism inside of the duct. So we ended up developing the first monitor that doesn't require a little fan, a little pump to move air across it to sense those contaminants in the air. It actually just uses the existing heating and cooling system to move air passively across the sensors.
It seems like that would be a big problem with the wearable sensor. Is how do you get enough air? Is it passive or is it something that's more active and actually pulling air? Sounds like that's something you wrestled with.
Yeah, and actually every countertop air quality monitor today wrestles with the same problem, which is in order to accurately sense what's in the air, and specifically particles are the biggest challenge because you need to physically move them across the sensing area at a fixed flow rate, or you have to be able to know the flow rate is kind of what we understood. And every single one of them, the fan blades turn into essentially a filter, and the dust lands on the blades, the dust lands on the aperture where the air is going through, it lands on the sensor, and over time it gets contaminated. And the bearings in the fan or the pump wear out. It's very expensive. Fans and pumps are very expensive. And so one of the biggest problems we see with air quality monitors on the market is their longevity. They work great for the first 3 months, 6 months, but we've done quite a bit of research that look inside of them after 6 months, and a lot of them are not sensing what's actually happening in the air anymore. They're occluded, essentially.
They're clogged up, essentially. They've got too much particulate that's been brought through and never cleaned. I mean, you got to clean and calibrate these types of sensors from time to time. Let's talk a little bit about integrating HVAC and IAQ. There's been some efforts toward that in the commercial world. Johnson Controls and others have CO2 sensors, and I'm sure they've got some kind of particle monitors. Nowadays I haven't seen any in any buildings, but there's been some efforts. I know in the past there was an IAQ Air, I think it was called, and they had a little sensor that they would put into buildings, and it would get your particulate and CO and CO2, et cetera. And then it would go up to the web, and some of the mechanical contractors would use it to help them monitor facilities. Is that the type of, I assume you looked at all that when you started this and decided that there was something missing. Can you tell us a little bit about what you thought when you looked at what was already available?
Yeah, that's a good question. There's definitely solutions out there. I think CO2 is the most common. And so there's this concept of demand control ventilation, where a CO2 monitor in a building would trigger at a certain level the ventilation to open up. And that's a primarily commercial application, and it's primarily for the purpose of energy savings. I think with the COVID-19 pandemic, that's changed a little bit, where how we think about CO2 has changed. It's now about the exhaled breath being a proxy for what could be in the air. And we want to get rid of that. And so definitely we looked at what was on the market, but there appeared to be a gap in the sense that air quality is about much more than just CO2. And while you could take these discrete sensors and try to plug them in, the cost of all these discrete sensors was pretty astronomical. It was in the multiple thousands of dollars. You need to have them all per zone. And then they weren't really stitched together in a way where you could make sense of the data and pull out insights. So we also looked at the fact that these sensors were built to plug into the building management system. Right. And a lot of light commercial and residential buildings don't have a complicated building management system or building automation system to be able to capture this information and plug into. So really the big opportunity we saw is that most residential buildings, and specifically single family homes, actually don't have any form of ventilation, any form of airflow or circulation. And a lot of the codes aren't quite built in a way that we have safe havens to spend our lives in and to raise our families in. That's been really the mission that we've been driving towards.
Well, let's take a look at what you've developed here. John, if you could put up one of the graphics with the sensor in the duct there, or here we're seeing it on the outside of a return air duct. Kevin, can you just give us a little explanation of what's going on here?
Yeah, so our product installs into the duct in the return side is primarily what the application is of this product ecosystem. And yeah, what you're showing there is the monitor, and that can slide out of the duct in case it needs to be cleaned, which we see sometimes with drywall renovations. The product on the right is the controller. And that's actually our brand new product because we want to be able to take the data from the monitor. We want to be able to activate the central system and even indoor air quality equipment like ERVs or dehumidifiers. And so those two products, the one on the left is sensing what's happening in the duct, including temperature, humidity, and airflow. And the one on the right is simply a 24-volt relay, and it is able to trigger low voltage controls on equipment.
John, let's show it inside the duct real quick. So here's the sensor, and tell listeners a little bit about what parameters you're measuring here.
Yeah, we're measuring, so the red glowing particulate that had crossed through, that's the laser sensor, and it is detecting the PM 2.5 in the air. In that same aperture, there's an air velocity sensor, and that allows us to know what the volumetric concentration of particulate matter is in the air. In the other aperture, there's chemicals, so volatile organic compounds, temperature, humidity, pressure. As well, we have an option for CO2 in our product.
Oh, you do? Okay. Okay. And
we've kind of built the tricorder inside of a single duct-mounted probe.
It's interesting that you're kind of using the air movement within a duct. How does that affect, like when the duct's on, when there's air when the mechanical system's calling for air and you're getting air coming in through your return air versus when it's shut down? Or do you just have people put the fan in the on position?
With the controller, we can control what the fan is doing. I think in our application, we have a lot of Nest thermostats or a lot of Ecobee thermostats that are connected to these systems, and a lot of them are shut to off. And so with the controller, we have the ability to hook that up to the G and the R on the air handler. And when we close that circuit, it's a dry contact relay. When we close that circuit, the system turns on with the fan, not with heating and cooling. It's just simply for circulation. And so that allows us to program on a schedule an air change either once an hour or twice an hour or whatever the user wants to define. And so based on that, we can take measurements. Based on that, we can have the world's best filter in line in that system, but it's not going to be doing anything if the airflow is off. This was kind of one of our insights, is that you can have the best indoor air quality equipment, you can have the best filter, but if your air isn't moving, it's actually not doing anything. And that's really where this controller comes in.
And if you don't get all of the air in the room into that mechanical system, if you have dead areas, et cetera, that they're not going across your filters or across your coil to, rinse out, wring out some of that humidity. Let's talk a little bit about the location of the sensor. I would imagine you looked at different options. Are we really measuring the indoor air quality in a room by measuring the indoor air quality in a return side of an HVAC system?
Yeah, that's a question that came up a lot because this concept of in-duct monitoring is quite a new concept for a lot of people, especially in residential. What we're familiar with is the countertop units that are actually in the room measuring. Right. And what we've realized is that if I have a countertop device beside me right now, I'm basically breathing right on it. So there's going to be CO2, there's going to be VOCs in my breath. And humans, we are the creators of quite a bit of our air quality issues. There's particulates that come off of us as we move around. And so these room monitors, they tend to have a lot of what I would call false positives, where they see hyperlocal events and they react to those hyperlocal events. We see the return duct and specifically the plenum coming back from a zone or from multiple rooms, and in some cases that represents the entire building or the entire home, that is a better indicator of, on average, what's happening in the home. And we say it's not about one bad breath. So just having a spike of air quality, that isn't going to long-term create any harm. What is concerning is when there's events that are of a certain magnitude, like a cooking event that could last multiple hours in that home. We see that coming back almost immediately into the return duct. And if you think about air is moving at 2 meters per second, 5 meters per second, or up to 1,200 feet per minute. And as a result, we're able to see this cooking event or a chemical event very quickly once it happens. It's reaching typically within less than a minute, sometimes less than 30 seconds. Even though the heating and cooling system may feel far away, it tends to be fairly close on a temporal basis. So we're resolving events quickly. And we found that a lot of air quality events will be homogeneous in the sense that they spread, they diffuse through the air, and they diffuse specifically into the return duct where we can measure that concentration and be very confident that this is a real air quality event. So when it comes to controlling heating and cooling, countertop units can create false signals for that system to work off of. In-duct monitors, we feel, are a very reliable way to do measurements, but there's also issues that come along with that. For example, if the ducts aren't sealed properly.
Really dirty, I would imagine, is not a good thing either.
Exactly. And sometimes we can detect that, and it can actually create a new opportunity to seal the ductwork. And we're actually starting to see that our data, the pressure data, the velocity data, the particulate data, it actually is becoming a measurement of, is the heating and cooling system installed correctly? Is it commissioned correctly? In some cases, you can actually adjust the sensible to latent heat ratio to take care of some of your humidity issues. And that comes down to how you essentially commission the heating and cooling system from the first place. So, and even sometimes it's that the filter wasn't sealed in properly. So we're seeing many opportunities where this product isn't just about indoor air quality. It's that your heating and cooling system has to work properly in order for you to have comfort, in order for you to have indoor air quality at the level that we want to get it to. And so that's a very important component that we're going to be moving into on our roadmap.
I would imagine you've done comparisons of that in-duct data that you get back and then looked at maybe monitors of some type out in the actual, in the rooms or in the supply lines, et cetera. How does that compare?
Yeah, we have, and there's a high correlation with what we're seeing, meaning that the R squared value is close to 1. And meaning that when there's an event on the room monitors, we can see it with our in-duct monitor. The difference is that some of the hyperlocal events that are little blips, like popcorn is a great little blip through a room monitor that gets kind of smoothed out. It's almost as if we're applying a smoothing filter in the return duct because we're mixing air before we're sensing the air. It's kind of like a mixing chamber in a sense. And we're confident in that sensing mechanism. We have quite a bit of data that we've done. We instrumented, I believe, 5 homes last summer, and we looked at all the data, and we've had third parties look at the data from rooms versus in-duct, and we've been able to compare them and see that they are in fact correlated most of the time. But an interesting discovery is that the size of the building matters, the size of the zone matters, or the size of your home matters, which has interesting implications, because if you're in a 2,500 square foot home versus maybe a 700 square foot home, there is more distribution of air to different locations that may have clean air. And simply by circulating the air, you're able to bring some of the clean air back into the room that's having the air quality event. And so you can actually use almost your home as a solution to pull some of the clean air and mix it with the dirty air. And I guess it's this common principle of dilution is the solution that we have in this industry.
Cliff, do you have a follow-up?
Yeah, I do. You know, you mentioned homogeneous contamination and so on and so forth. It got me to thinking that, you know, what if something bad happens in a building, such as a fire, and you have soot and char and ash, and you know, it kind of gets blown through the building. And let's say that this is a building or home that does not have your system. Could your system be installed on a temporary basis to, number one, determine what's going on in the system in terms of particulate, in terms of the VOCs, in terms of the velocities, and so on and so forth. And what happens is the insurance company is responsible for the remediation, so that after the system was cleaned, after the ducts were sealed, after the filters were changed, and so on and so forth, then the system, could be run again on a temporary basis to show, was the remediation effective? Was there an improvement? Is there an improvement? And then it would almost seem that if someone saw that, they'd probably want the system all the time, but I'm just wondering if it could be, installed kind of on a temporary basis by people that do duct cleaning, restoration, remediation, so on and so forth.
Good question.
Yeah, that's a good question. And it brings up a point that we've heard from potential customers. It definitely can be installed on a temporary basis. And actually, when you use the app that we built to install the device, there is an option for temporary assessment right in there. And what that allows you to do is install it, capture information, decommission the device, and bring it into a new building, and then install it again, take more measurements. And there's sort of a line that gets drawn between the previous assessment and the new assessment. And we'll be working to the future on generating special reports. But I think to your point, when someone experiences that they have this information, it's kind of game changing, because now you have season changes, you have diurnal patterns day and night in the home, you have cooking events. And so this information really allows you to not only know that there's certain behaviors like not turning on your hood fan that you can improve on, but it actually activates, controls those solutions. And to your point about insurance, we've actually had numerous air duct cleaning companies approach us who do emergency remediation for those exact types of events where you do need to prove to insurance that the problem has been solved. And a lot of the cases, they go to extraordinary measures to take the curtains and run it through a special machine, run carpets through a special machine.
Right.
And so definitely we could act as a piece of evidence that the, building is now back to a safe condition.
Thank you.
Kevin, somewhere in the prep for the show, I read that the particle count sensor in your technology is a little different from what you would find in, I don't know, I've got a couple of room particle counters, is that true? Is your sensor a little different?
It is a little bit different. And I guess we've kind of touched on a little bit of it where we don't have a fan or a pump for the particulate sensing specifically. So we actually built our own particle sensor. We have our own laser that we custom developed. We built the mechanical system, the beam dump, the light sensor. We've really assembled our own sensor that it doesn't just come. Almost every air quality monitor that you can buy right now on the market, they've taken a particulate sensor off the shelf and they plugged it into their circuit board, and they've kind of positioned an inlet and an outlet. We've actually built from scratch our own particle sensor, and so it is quite unique on the market. But one of the most unique things about it is that the way that the air flows through the sensor is completely open. There's no obstructions for contaminants to hijack onto to get accumulated onto the surfaces. So we've engineered the surfaces. We've done a lot of CFD analysis to make sure that contaminants aren't going to stick anywhere in the sensor. And even if they did, you can pull the sensor out of the duct and you can clean it with compressed air with a Q-tip. And so it's an extremely easy sensor to maintain. It's very reliable and it lasts for a long time compared to other types of particulate sensors. So from that perspective, it's quite different in that it doesn't use that fan or pump to move the air across it. And then I guess the other part of it is that the air velocity sensor is part and parcel of the laser sensor, in that we can't resolve what is in the air without knowing what the volume or what the velocity of air is going through the laser sensor. And so that airflow and particulate sensing is basically done in the exact same place, in the exact same location. And we've built algorithms over the years and individually calibrated every single sensor. The airflow sensor gets mass flow calibrated. The particulate sensor, we actually generate particles and calibrate every single sensor from factory. And that goes out to the field fully calibrated and lasts for the lifetime of the device. And so in that sense, it is a very novel sensor that we have patented over the years.
So you don't send them in for recalibration ever?
No, we've actually fully characterized that exact device, the exact way that the laser was inserted, it was epoxied in place, all the characteristics that make it unique from one unit to the next unit. We call it unit-to-unit variability. We've ensured that we have fully characterized all of the nuances to that exact device. The plastics might be slightly different than the next set of plastics. And so once we've calibrated that, it doesn't change in the field. It's sitting there in the duct for 5 years, 10 years. There's no need to recalibrate it. Where the calibration would drift is if the actual power of the laser changed, or if contamination formed on the aperture of the sensing region. And so we actually look for potential contaminants. We can sense that. And yeah, in general, we have recalibrated sensors. We have the benefit of, I've been doing this for 8 years. We've had these sensors in the field for a long time. We brought them back in for recalibration, and we ended up getting the exact same results as the initial calibration, and determined that there was no benefit to recalibration.
All right, we're going to break for halftime, Kevin. We'll be back with Kevin Hart, the CEO of Haven IAQ. Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at instascope.co. Association sponsors are AIHA, Healthy Workplaces, A Healthier World, AIHA.org, ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science, ACGIH.org. The Cleaning Industry Research Institute, see more deeply through science and research, CIRI science.org. The Indoor Air Quality Association, IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, restorationindustry.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Healthy Buildings America, Honolulu, Hawaii, January 18 through 20, 2022. HB 2021-America.org. Industry sponsors are AEML Laboratories. Free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. Gray Wolf Sensing Solutions, over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring. GrayWolfSensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations. TSI.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. All right, we're back with the second half of our interview. We've got Kevin Hart, the CEO of Haven IAQ, and we're talking about linking IAQ and HVAC with sensor technology. Interesting stuff so far, Kevin. I want to ask a little bit about how you determined what contaminants to monitor for and what levels you consider to be. I noticed on the dashboard, John, can you put the dashboard up real quick? That comes with these, when you download the program, I guess you get this dashboard that you can monitor, I guess, through the web. Here we go. And I'm curious as to how you determined what levels were good, fair, poor. So let's start with how you chose the contaminants. It's particles. Well, you go through it.
Yeah. I mean, we looked at what are the components of our atmosphere? What's the components of the air we're breathing? And there are the gas, the chemical components. There's the physical components, the particulates, and any solids versus the liquids. And then you've got temperature and humidity and pressure. And so those were just broadly the, let's call them buckets. They're the buckets of what's in the air that we care about. And we took a very broad approach. And so I think there's a tendency in the indoor air quality industry, we want to speciate what it is. We want to know, we don't just want to know that it's a volatile organic compound, because what's the toxicity of that VOC? We don't know what VOC it is, right? Is it ethanol? Is it formaldehyde? And so there's a necessity to speciate what it is in the air. Now, our product is not intended to speciate, and it's not intended to replace instrument grade sensors or monitors in this industry. And it's not meant to replace a certified industrial hygienist or any other professional in this industry who does this work. What we're trying to do with our product is take those buckets of there is stuff in the air. There are particulates in the air. There are chemicals in the air, or the humidity, or I think a better measure is the dew point in the air is not in a generally safe threshold. And the reason we don't care about the speciation is because as long as there are things in the air that shouldn't be there, there are solutions to that. There are ways to filter out the particulate matter. There are ways to bring in fresh air and replace the stale air. And so for us, we're not really in the business of speciation. We're in the business of just knowing and then reacting accordingly. And so our sensor platform will evolve to be a little more specific, only for the purpose of knowing how to solve the problem, but not for the purpose of creating a report that tells you your tooling levels inside of your building.
Who's your main customer?
Our main customer is, at the moment, the heating and cooling contractors who serve millions of homeowners, and specifically the homeowners who live in homes that may not be healthy and may not be safe for them. And really, so we think about those two stakeholders, and we think that that's one of the biggest opportunities we can solve. Not to say that we won't expand over time into additional buildings such as light commercial, where you have fitness centers, dental clinics, and these facilities, they're pretty much using residential systems. They don't have building management systems. And so they're sort of somewhere in between residential and commercial, in the sense that we can still be a benefit to their building. And so we're definitely going to be expanding. In fact, schools and gyms, these are some of the most occupied environments that need the best indoor air quality. And yet they don't have some of the sophisticated indoor air quality solutions that would be available with a very commercial or industrial building. They're more akin to a residential system, which lacks some of the intelligence in demand controlled capabilities. And so our current way of thinking about our customer is that the professionals, if given the proper education, the proper product offering to resell to all of their customers, we can now affect millions of homes' air quality. And that's one of the primary missions we have in our company.
I was looking at the website and I saw, I don't know, $700-800 was the cost, I think, for just the sensor. Does that include the controller as well?
Yeah, so our price now is bundled. So the controller and the monitor come together. And we don't, at the moment, define what the price is, from the sense that we go through a two-step distribution process, and the professional may have a different rate for the labor that they charge. Right. There's different situations. If they're doing a truck roll just to install the product, it may be more expensive than a condition in which they're already in the home to do a servicing or to install equipment. And we're actually seeing a lot of cases where our product's being bundled with a media air cabinet. It's being bundled with an ERV. We could even see in the future it bundled with a new home in residential new construction. So it's actually part of the home when you move in. So there's quite a bit of variation in what the end user may see in terms of price. But in general, we always try to keep it less than $1,000.
Well, I think that's an important point. You know, that's a big break point for people. Less than $1,000, greater than $1,000, it's going to help improve your indoor air quality. I think the other selling point is it doesn't just like my monitors, my spec or whatever. It tells me there's a problem, but it can't do anything about that problem. Let's talk a little bit about how your module or your sensor can be tied to either the fan on the mechanical system or an ERV or an HRV or a dehumidifier. How does that work?
Yeah, and I mean, I'll just be honest and transparent about some of the issues we're encountering as well. Is that we are trying to create a new category of product, and so we are being bucketed in with indoor air quality monitors. And when you think about a monitor for less than $1,000, that's expensive. I could get a monitor for $100 or $200. Why would I spend more? And then you look at a Dyson air purifier or room air purifier, and they can be $1,000. They can be $2,000. They can be $500. And in a lot of cases, you may need multiple of these room air cleaners or room air purifiers in order to have coverage across your whole home. And that can be thousands of dollars. And so another way to think about our product is that we are essentially creating a whole home air cleaner. We're creating a whole home air treatment system, and we're leveraging the existing investment in your heating and cooling system, which is one of your most valuable assets, in order to move the air and clean the air. And so it's actually a very efficient way to get filtration at a level of what we call the clean air delivery rate, or CADR, which is what room air purifiers are rated at. It's a unique way of thinking about the problem, but getting the industry and getting homeowners and building owners to think about our product, not as a monitor, inexpensive monitor, but actually as a whole home air treatment system, is a struggle to create this whole new category and to have people value it or perceive it in the right way. And I guess to your question about how do we do that, we're using the central air handler and a filter to move the air and filter the air. And so we think about the three pillars. The three pillars in our eyes for indoor air quality are filtration, ventilation, and humidity control. And all three of those pillars create good air quality, and they sit on the foundation. If you think about the three pillars, they're sitting on the foundation of air movement. We need to be able to move the air and circulate and get air changes per hour, or air ACPH, in order to have clean air. And so a lot of what we do is about air movement. And we're seeing that air movement is something that is very underrated in the air quality industry. We're very focused on having the best filter, but not what is the duty cycle being delivered into this home, and how does it react to a pollution event in that home or building.
Cliff, you got a question? Text question?
We've got a text question, Kevin. The text question is, this technology might be substantially valuable to homeowners, especially those with chemical and microbial sensitivities. However, these same people often are sensitive to EMFs. This might disqualify the present offering for some of the folks. Is there an option for non-wireless?
Yeah, that's a good question. And there was also, I think, another concern that's come up, and it's related, which is, if this system is online on the internet and your internet stops working, does the product continue to work? And so both of those concerns are related to the internet connectivity layer of what we do. And we're actually working on an offline capability, so that if you have an EMF sensitivity, or in the case that your internet goes down, there's still going to be operation. There's going to be a closed loop system where above a certain threshold, the controller will be activated and will turn on the system until the air quality is back down to a safe level. And that capability, we're aiming for 2022 release. We're confident that that's a feasible timeline. And that's an important capability, even for homes that are unoccupied because they're a brand new home. We want to be able to have this benefit, this capability from day one. The thing is that a lot of the value of the product comes from the internet connectivity. And I don't mean that from a business perspective. I really do mean that if you have a acute problem, we can solve an acute problem with the solutions in your home. But if you have a chronic problem, if your home is constantly above a certain level of dew point or relative humidity or chemicals, it may mean that you're actually missing a piece of the three pillars in your home. And I think, Joe, you mentioned having dehumidifiers in your region. If you're in a region that has a tropical humid climate and you don't have a dehumidifier and your air conditioning system isn't running long enough, you may have a humidity issue, which could be creating all sorts of byproducts, whether it's mold, bacterial growth, et cetera, moisture issues. And so we really think it's important to be able to get the data out of the product to assess if the environment is in fact the clean environment that we are sort of in a sense promising that it would be with our product installed.
I tell you what, the people like me will like that option you're working on, because I don't want my stuff going up on the web. I'm an old guy. I don't like it. I just think somebody could hack it or steal it or whatever the case may be. And I also don't like all that wireless stuff going on. Most of my system here is all hardwired in. So I think it's interesting you're working on it. Another question along those lines, Kevin, is this: the system you've developed right now, it sounds to me like it's required essentially that you have forced air is oftentimes the way we refer to it, mechanical system with ductwork, et cetera. Are you working for anything in homes like mine that I don't have forced air, but I do have some ventilation through, I've got a dehumidifying, filtering, ventilating system, and like April air cells and others. Can it work in a home where I don't have central air?
Yeah. This is a question we got a lot early on. And
how many, I'm curious, do you know how many residential homes have central air versus, up where you're at? You're going to have a lot of boilers and things like that.
Yeah, you get baseboard heat,
radiators.
Yep, exactly. So, I mean, the research shows that there's, in North America, so including Canada, where I am, there's around 100 million single family homes. And out of those, there's actual American census data that tells you how many single family homes there are, how many of those homes have heating and cooling, and how many of those heating and cooling systems are specifically central ducted systems versus potentially a mini split type unit or radiant or another form. And the vast majority are centrally ducted. And so it was more than 60%. I don't have the stat on me, so don't quote me on that, but there is a majority centrally heated and cooled in North America. And to be, I guess, because this question came up a lot, and it's always, this need to want to serve every single customer. But what I've learned over the years is that you're not going to have great air quality, or you don't have the potential to have great air quality if there's no air movement. And it kind of comes back to our core thesis, is that circulation, that air movement is a requirement for good indoor air quality. And so if you're recirculating or you're convecting hot air, I just haven't seen the capability there to have the level of filtration, to be able to move all of your air that could be stagnant, air that could be filled with off-gassed chemicals, or that could be filled with cooking particles. You just don't have the capability to solve those issues with the current infrastructure if you only have radiant or baseboard electric heating in your home. And I think that's a major issue. I actually think there's a bit of a infrastructure issue that we have in North America in many residential homes specifically, where the capability isn't there to have good indoor air quality. And it comes down to how the building envelope is getting tighter for energy efficiency. So we have these tight building envelopes, or we have these leaky building envelopes, and we have almost no fresh outdoor air intentionally, mechanically coming into the home at a controlled rate. And we don't have the level of filtration that we need in order to tackle some of the air quality events that happen in homes. And we're still filling our homes with building materials that are off-gassing harmful chemicals and like formaldehyde. And so like there is a public health crisis, at least in my eyes, of what residential homeowners are living in for often 90+% of their time.
Good point. That's an interesting point. Let's go to the roundup, John. The roundup is brought to you by AprilAire, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. AprilAire, healthy air, healthy home at aprilaire.com. All right, I got another question here, and that is one of the complaints about ventilation and other IAQ improvements is financial, obviously. Does the system do anything to help with monitoring energy performance, or have you noticed maybe some side effects that help with energy performance?
Yeah, and energy is, I think to the previous conversation we were having, energy is a big focus for building codes. It's a big focus for governments around the world as it relates to climate change. And energy can be improved by having a tight building envelope. And so what we're seeing in sort of the passive home movement is this very intentional bringing in of outdoor air and solving air quality issues through ERVs, enthalpy recovery ventilation, or energy recovery ventilation, or HRVs, or other forms of outdoor air. And so the energy component is very important for a lot of reasons. As the climate changes, we have more extreme droughts, which creates more extreme forest fires. We have smoke that is then coming into our homes. And a lot of homes are negatively pressurized, and that home gets the smoke inside during those events. So it's interesting because we call the product Haven, and a safe haven is a place of safety or refuge. And we kind of think about it in the sense that if these extreme events happen outside of our homes, we should be protected in our buildings. We should still be safe and healthy as the human species inside of the buildings that were constructed. And that's not necessarily what's happening today. And so the energy component of this, I think in an interesting way, is correlated to the air quality issues that people are experiencing. And so certainly air conditioning systems, if you think about them as part of the solution to increasing temperatures, we had a heat wave here in Vancouver that people just weren't prepared for from an air conditioning perspective. And lives were lost by heat stroke. I think 800 or 900 people passed away in one weekend due to heat stroke. And so really the comfort, it's more than just comfort. It's actually life, it's safety, and it's quality of life, it's wellness. But that energy component is so important. And so if heating and cooling solution is part of solving climate change, is part of good indoor air quality, well, they're also one of the largest consumers of energy. And so you almost have this cyclical problem where we're going to need more air conditioning to solve an energy crisis, which is going to create more energy issues. And so certainly energy is an important facet of what we do. And we are capturing information during the install of our products, such as, is this a high efficiency system? Is this a electronically controlled motor? Or is this a PSC motor? And what we're doing with that information, over time, we're going to be adding energy monitoring, whether it's through a partnership or whether it's eventually releasing our own component of being able to monitor the energy on the heating and cooling system. And we're looking at how much energy consumption is normal for a system of a certain size, for a certain home. And I think over time, what we're going to see is that heat pumps and innovative solutions are able to decrease the amount of energy consumption. And I think we're also going to see that if you intelligently control the amount of outdoor air based on air quality parameters, such as demand control, ventilation, and filtration, you can actually lower the overall energy consumption of a system that might be normally on or might be following ASHRAE 62.2, ASHRAE 62.1 standards for ventilation for acceptable indoor air quality. Those generic standards and those generic air changes per hour and outdoor air exchange rates may be too little or maybe too much for that particular home or building at that particular time. And so by intelligently controlling this, we actually believe that there's not a compromise between health and energy. There's an optimization of both. And so there's a bigger picture here. There's also the maintenance issues. So if you don't change your filter, your ECM motor is just going to keep working harder and harder to move the same amount of air, depending if it's a constant torque motor or how it's set up. And we see that we can actually identify that the system needs maintenance. That filter needs to be changed, or your energy consumption is going to be higher than it should be. And so there's a lot of reasons why energy is an important piece here that we're working towards over time.
What about the problem of outdoor air? You're not comparing the outdoor air to the indoor air, and you could turn on a ventilation system during a wildfire situation. How do you handle that?
Yeah, I feel like you're our product manager building our roadmap for us. This is exactly on our roadmap. So
we take donations, so feel free.
We definitely don't want to be bringing in smoky air. We don't want to be bringing in a delta T unnecessarily. It's sort of like peak demand energy. You don't want to be using energy at the time of the day where it's most expensive or where the grid is under the most amount of stress. And so definitely there's going to be opportunities to say, hey, let's change the mode. There's some ERVs now that have a recirculation mode where they can shut off the outdoor air supply and recirculate temporarily. And so, and potentially even if there's a negative pressure in the home and there's a makeup air unit or there's exhaust fans such as kitchen hood fans or bathroom exhaust fans, eventually we want to be able to integrate with any piece of equipment that moves the air. That includes bathroom exhaust fans, that includes kitchen hood fans. And so being able to potentially positively or negatively pressurize the home, depending on what the outdoor air environment is, could be beneficial depending on the season and depending on the climate zone. And so really there's a big data problem here, which is, every home is different, every home is unique, every climate zone is unique, the types of construction and materials used are unique. And so almost every home needs a custom solution. And so how do you do that at scale without having experts, where we don't have enough experts to solve this problem? We don't have the scale.
The data either.
What's that?
We don't have the data either. You don't. I mean, you don't. Exactly. You don't know. Okay.
And actually, a lot of the early indoor air quality parameters that people looked at were just a subjective survey. How is your indoor air quality? They would survey. You probably know this. This was the primary mechanism of determining whether or not indoor air quality was good, was just asking people. And the problem is that people have different levels of sensitivity. You have people with MCS where they're chemical sensitive. You have people with asthma. And there's a varying spectrum of people who feel the immediate acute symptoms of air quality issues, but it doesn't negate any long-term chronic issues that are occurring that might not show up right away as itchy eyes, sore throat, headache, other types of symptoms. So yes, it's very important to move away from the subjective measurement of air quality and move toward a more objective measurement of air quality. And I think that speaks to, we're seeing a little bit of a silver bullet, especially out of this COVID-19 pandemic, that, I'm going to install this air treatment solution and it's going to solve all of my problems. And by the way, I didn't even know what problem I had to begin with. I don't know what my 3 pillars are. I don't know what my air changes per hour are to begin with, but I'm going to install this thing and then I don't have to think about it anymore. And we see that's a little bit dangerous because it may not be true.
Yeah. Cliff, any final questions?
No, it's just, I guess just a comment. I think it's brilliant. Your design of the sensor and not having the pump or fan inside of it. And it's just so stupid not to have some sort of fan system inside of a home to circulate air, just rely on stack effect or something like that. And, I was just thinking that, you fill a balloon up with helium and the balloon rises because that's one of the few gases that's heavier than normal air. So, the heavier that it is, probably the lower in the home it's going to be. And if it doesn't get to move and doesn't get to circulate, it's a problem. So
good luck. Yeah. If you think about where you spend your time, you might be spending your time for 8 hours at night in your bedroom. And if the door is closed, the CO2 levels can rise to pretty extreme levels. If right now I'm in an office that's enclosed, I could be in the kitchen, no matter where I move, kind of the air quality event follows me, and being able to circulate the air. So if I'm right here in the office, my CO2 levels are increasing. It's okay because I have a return duct above me, and it's taking this air and it's dumping it out in the bedroom, or it's dumping it out in the living room, and it's bringing in air that doesn't have those high levels of CO2. And so we kind of think about like averaging the extreme pollution event across and distribute it across all of the volume of air in the entire home. And yeah, it's a very different way of thinking about solving the problem.
All right. Well, I tell you what, Kevin, this has been very interesting. Before we go, do you have any final thoughts? Anything you'd like to make sure the audience hears before we go?
Just if anybody's interested in what we do, I don't know if you're going to be advertising, but our website is haveniaq.com. That's it.
Fine. All right. Well, thank you so much. It was very interesting. I'm glad we were able to get you on here in short notice. We appreciate that very much. And we'll be keeping an eye on Haven IAQ. Thanks so much, Kevin Hart, for joining us, CEO of Haven IAQ. I want to thank the Z-Man, my partner, my co-host. Of course, John, you got to have faith, our engineer at the controls. Most importantly, our growing group of loyal listeners and our audience and our sponsors. And next week, we've got Sarah Haynes. Some of you may have remembered Sarah. She worked with Karen Dannemiller at Ohio State University. She's since moved up to Toronto, University of Toronto. We're going to have her on next week. We're going to talk about some microbial research she's been doing, and get caught up with Sarah. So we'll be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.